Hey everybody, thank you for clicking on this video. I really appreciate your support. So today we're going to build a binary clock. It comes from the Popular Electronics magazine and it's the January 1991 issue. So let's take a look at what we've got so far. We have all the components, which by the way, I already had in my components used, brand new. I've got pretty much everything. Sometimes I do have to order brand new parts, but in this case, I got lucky and I had all the components. So we've got the IC chips, simple CMOS type chips, 5-volt regulator, resistors, capacitors, and I've got a power supply, the adapter. The way we're going to do it is we're going to use a double-sided board, and it's the photo etching method. So I'll try to be as quick as I can with that because it is a bit of a long, well, not long process, but for a video, it might take up a lot of time. So I'll try to be really short and sweet when it comes to that. Maybe on a different video, I'll explain the process a little bit more. However, there's plenty of videos out there on YouTube that show this process, plus many other processes. So I've got the PC board design. There's two parts to this, the upper and lower. And the way it works, binary clock, as you can see, the columns are what we're going to be reading, starting from the left. The very first column has no LEDs lit up, so that means it's a 0. The next column over is, we've got the 1 at the bottom and 8 at the top. Add them together, it's 9. And etc., etc. That's how the binary clock works. So let's get ready. I'll get on to the photo etching method. I think that's probably where we are at this point, and I'll get right back to you. Okay, I'm back. All right, so let's get on with the PC board. I'm using the photo etching method, and with that I require transparency of the actual board itself. So I've got side A and side B. I am using these clear transparencies. I printed them out using my LaserJet printer. I've got a HP 2300, and this is the result. Now, first of all, I have to be honest with you. The actual quality from the Popular Electronics magazine isn't the greatest. It looks okay, but there are some light spots in there. And I expect we're going to have to fix some of the traces once we've etched the board. But for now, let's just go with what we want. Now, the very first and most important step is when we place the transparency on the board, we want to make sure we've got it the right way. And in this case, I've got it on the right way. So pretending that white piece of paper there is our board, we want it the way that makes sense. Of course, that matches up with the other board. But the clue, or actually a good tip when we're looking at these boards, is the lettering. This is the way we want it to be photo etched onto the board. We want to be able to read that 798 EKI ink. That's the side we want facing us. So that's what's going to be showing us when we've actually etched the board. And in this case, I'm just showing you the other side here. Now, this isn't the board we're going to use. This is not a photo etching type board. But again, in this case, I do see some lettering here. And there you go. You've got the 798 and the EKI ink. So that's the way we're going to be placing it on the board when we're ready. Now remember, the photo etching method, we've only got a little bit of time to actually get this lined up. And the way I'm going to do it, and I'll show you that in a bit, is I'm going to use these corner holes here as a reference. Because you can imagine trying to line these two boards up on a PC board using photo etching. We have to be pretty precise. Some of these holes aren't that big, and we want everything to line up with the other side of the board. So let's get set up for that, and I'll get right back to you. Okay, I'm back. So I've got the board prepped just to make sure all my alignment is correct, and I got it cut. And I use this office type cutting board, I guess is what you call it. Now, what I noticed is when I did cut the board, there are some bubbles at the bottom here. So luckily I cut the board, well, in fact, I cut the board bigger than the actual circuit board itself. So that gives me a little bit of room to play around with. I can obviously, once the board is etched, I can actually cut it to the right dimensions. However, it's good to leave a little bit. And in this case, it's going to help because I needed that extra space for these bubbles. Now, I did tape them up with some Scotch tape just to make sure no light gets in there. Now, I don't know if any will, but just to be on the safe side, I've actually pushed the board layout up. And by the way, if you're looking for boards, I suggest the MG Chemicals boards. They're fantastic. I've used them for a long time and they work well. So there's no complaints with that. They are maybe a little bit more expensive. I don't know if that's the only board in town kind of thing. You'll have to check where you are, what country you are. Maybe there are some other boards. In any event, I use MG Chemicals. You can buy these boards from DigiKey, Mauser, all the rest of them. So what I've done, now I printed this out on a piece of paper, as you could tell. Now underneath this white paper or white plastic is the actual board. Obviously I don't want that exposed because with the light right here in the lab, it's going to ruin the board essentially. So when we're ready, I'll go to the actual light that I have, and I'll show you that in a bit. I'll peel off the plastic and I'll use the transparencies, which I have over here, and I'll put them on the board and then photo etch it. Now, I just wanted to put paper on first because that way I can assure myself of the alignment. So on this particular side, now we've got this big square part here of the circuit board, so that's a good reference. And also I've got the lettering here, I've got it correctly. And then I've got on the other side, I've got the same thing. So I've got this square thing here, and I've got the lettering correctly, so that it's going to be etched in that the way it's placed. So again, the square part is here. So I'll flip it over one more time, and I'll show you where the square part is, and there's the other square part for the other side. What I've done is I've actually etched, and drilled. I don't know if you can see it. I've drilled tiny holes in the board. So those are our alignment points, if you want to call it that. So when I take the plastic off and put the actual transparency on, I'll line it up to those holes. So that'll give me a good reference. And I'll do each side separately, of course. It's about 4 to 5 minutes under the light. And then we'll put it in some positive developer. I'll get into that a little bit later. Just as a point of reference, when I made these transparencies and when I cut them out, they're actually bigger than the actual board dimensions itself. I'll show you here. And I just did that I left like about a ½ an inch or whatever on each side, just so I have some room to play, because I'm going to have to place this transparency pretty quick onto the board. So I want to have some ability to actually move that with my fingers up and down and sideways, etc. So I think we're ready. So let me get the light set up and the whole photo etching thing set up. So I'll show you that in a bit. So hang on. All right, here's the setup. This is where I develop the board on the left and then etch it. Oh, and here's the positive developer. I'll show you all the steps necessary to make a photo etching board. Clearly, you could see I don't live in a mansion. However, it would be nice to tear this house down and build a new one and have a nice lab. Anyway, it's what we have, so let's just deal with it. The first step, we're going to put the board on that wooden platter. And, well, first we're going to take off the plastic of this, put it on the board, and then I have a plate glass. I'm going to put that on top of the board just so it doesn't move around. And this UV light will actually etch the traces onto the board. I just bought these 2 short fluorescent type lamps and put some legs on them, and that seems to work. Then once that's done, both sides, by the way, so once I do the first side, 4 to 5 minutes, I'll flip it over, do the other side, make sure all the alignment points are set up, and then when that's done, I'm going to go over here and put it in this solution. So this solution's positive developer. That will essentially develop a trace on the board so that we can then put it in the etchant. It's a 10-to-1 mixture, so this stuff should last for a long time. And I'll put it in there and I'll show you the results, the traces that show up after we develop it. And once it's developed, we're going to go over here to the etchant, put it in there, and wait for the copper to dissolve, and all we're going to be left with is its traces. So I built this kind of a fume hood, and I've got 2 fans on the top, as you can see, just computer type fans, 12 volts. And I put a little light bulb in there. Got that from an old vacuum cleaner, I think. And then the fan outputs go to the window here. So I just stuffed that in there. Seems to work. And of course I got a hot plate heating up the etching. Now you have to be very careful when you're placing dinnerware or any type of container for your etching. This is Pyrex. You don't want to put regular glass on there. If you're ever going to do any etching on a hot plate, you have to use Pyrex. All right, enough said, and let's get on with the process. So what I'll do is off camera, I'll actually develop the board, and then once it's developed, I'll show you what I have, and then I'll dip it into the etchant. All right, hang on. Okay, just a quick update. I've got the board, the first side of the board on, and as you can see, I got the fluorescent lights on, and I'm just waiting. I don't know if I can zoom into this thing. No, it's not working out. Oh well. Anyway, the point is I got the first side going. All right, hang on. Okay, just a quick update. I got my board photosensitized, and right now I know the lighting is horrible and you can't really see it, but I've got it in the positive developer, and I'm going to get all the green stuff off, and what I will hopefully be left with are the traces. And as you can see, when I was ripping off that plastic that coats the board, it just did a number on it. But we can maybe fix that. Anyway, I'm going to have to drop this so I can get it at the right time. Okay, so here's a quick update. I've taken it out of the positive developer, and this is the one side. Now, there was a problem, as I quickly mentioned when I was showing you the picture of the developer. When I took off the plastic, so these photo etched boards have plastic coating because obviously they're light sensitive. So when you're ready to etch it, you peel off the plastic coating, and then of course you put your transparency on, etc. Well, when I was ripping off the plastic, there was a bad spot here, so that you can see some faint lines, but I think we can deal with that. Shouldn't be that much of a problem. So this is the one side, and the other side is not my proudest work. You can see some, in fact, oh my gosh, there's a lot of lost lines here. Well, look, I'm already into it, so I'm just going to work with what I have here. And yeah, there's some traces definitely lost. My gosh. Well, we'll make something out of it. I think the next time when I do build another project, I'll probably use the toner transfer method. But anyway, let's now put it in the etchant and see what it looks like afterwards. All right, hang on. Okay, I'm back. The board is etched. It's, again, not my finest work. There was a blurry spot right in there. You could see some of the pads for the IC. They're touching, so I'm gonna have to fix that up. And some of the traces didn't come out too bad. You can see those two there. I thought they were going to be worse than that. Of course, I'm going to have to patch that. But overall, I think I've got a pretty good circuit board. All the holes appear to be lining up, so that's a big critical part of doing a double-sided board. Okay, all right, well, let me move on to the next step, and that's to drill the holes in the board, and then I'll put the components on, and I'll show you where I am at that point. I don't want to keep it too long. I know the attention span on YouTube isn't very long, so try to keep this as short as I can. All right, talk to you later. Hey everybody, I'm back, and good news, I've got the project working. Now, it did take a little bit of effort, in fact, a lot of effort, longer than I anticipated. So again, I think I mentioned in the previous short video before this, that the traces weren't perfect, so I had to fix them. Now, if I just kind of zoom in, you'll see some of the bodge wires I've put in the back on the board. And remember, this is a double-sided board, so you really have to line up the holes on this front side and the backside. So it was a bit difficult, but like I said, I managed to repair all the bad traces, and there was a couple extra ones that got by me, but anyway, I figured it out. There was one missing bit of information on the schematic. I don't think anybody's going to build this, but if you are, you'll notice these circles that I've got here. They're the ground points. Well, in fact, all of these are connected together. So if you were to just ohm those particular grounds out, you'll see they're all connected on one trace. Anyway, it should have went to ground, but it wasn't. It was floating. So anyway, I made that correction. I just put a bodge wire on the back from one of these points and to ground. So that got it going, and yeah, it's working great. So the way you read this clock is you're looking for the green LEDs. The red LEDs mean, you know, that's the default. So the green ones is what we want to look for. So in this case, looking at the hours, I see the first and second LED lit up green. So that equates to 3. So that's third hour. So 3 something. Now go to the minutes. We've got this column here. Second LED is lit, so that's a 2. So we got 3, 2, and then look at the next column for the minutes, and that's a 4. So 3, 2, 4. These are the seconds, and right now we're at 20. Oh, sorry. Now we're at 40 seconds, 42. Oh, sorry, that was 43, 44. 46, 47, 48, 49, 50. Now we've got the 4 and the 1 here, so that's 50 seconds. And then, of course, we're counting up here on the very far right. I won't be able to keep track of that. So that's the binary clock. I'm very happy. Oh, and there's some buttons at the bottom. So this is just a hold button. So if you look at that, it'll hold the count. And it comes in handy when you're trying to set the time. And also what comes in handy is this switch here. This will adjust the seconds. Yes, that will adjust the seconds. And then the next one over will adjust the minutes. It'll go really fast. And this one here is a reset. So maybe what I'll do is I'll press the seconds. I'll forward those fast. So let me zoom in here. So I'm pressing the button now, and you can see they're really flashing really fast. And the next column over is the minutes, so those are flashing really fast. And you'll see after 60 minutes, the hours accumulate. So there you go. So the next part of this project, and I'm not going to include it in this video, but the next part of the project is to put it in a case. So I'm going to put that into that, and then I'll be able to show you. So that's going to be for a different video. I'll probably end up making more videos. The Popular Electronics series seems to be catching on. I've got a pretty good viewership from a couple of other videos that I made. So I think I'll come up with another project from Popular Electronics. And in the beginning of that other project, I'll show you this inside of that, just at the very beginning. It'll only be a minute or two at the very most. So thank you for watching. I really appreciate your time. I know it's precious. And again, if you haven't subscribed, please consider doing so. And we're going to see you on the next Popular Electronics project. Subscribe, and you'll be able to see that. Thanks for watching. Bye.